sulfur dioxide is reacted with oxygen at a standard temperature and pressure condition to form sulfur trioxide as follows. So we're given the reaction SO2 plus O2 will form SO3. So SO2 is our sulfur dioxide and oxygen, then SO3 is sulfur trioxide. If 250 cubic centimeters of sulfur trioxide is collected, calculate the volume of sulfur dioxide gas fed in the reaction. So we have sulfur dioxide and oxygen as our reactants and sulfur trioxide as our product. But first thing that you need to do is to check if your equation is balanced or not. And in that case, you can see we have one sulfur, one sulfur, sulfur is balanced, oxygen 2 plus 2, get a 4, that side is 3. So we need to balance that. So in order to balance that equation, we can make 6 oxygens here. Then here, now we have 4, this side we have 6, so we need 2 more oxygens this side, so we make a 2 there. And now our equation is balanced. So our reaction is now SO2 plus 2O2 forming 2SO3. So now let's see how we can find the volume of sulfur dioxide gas fed. And another thing that we are told, this experiment is being carried at room temperature, at standard temperature and pressure condition. So what you need to come in your mind is, what is the molar gas volume at standard temperature and pressure? So the molar gas volume at that conditions is 22, which is molar gas, is equal to 22 cubic decimeter per mole. Then from there, we need to write the mole ratio of the reaction is 1:2:2. Then we find one species which can help us to find the number of moles. In this case, we have sulfur trioxide. We are given volume of sulfur trioxide. But with this volume, we know the molar gas volume. That one will help us to find the initial number of moles that will assist us to get all the number of moles of all the species in our reaction. Okay? So number of moles of sulfur trioxide is equal to volume over molar gas volume. Our molar gas volume said is this one. Its volume is 250 cubic centimeters. So we convert this one to cubic decimeters, it becomes 0.25. Then we divide it by molar gas volume. Sorry, this is 22.5. So we divide by 22.5. This gives us number of moles of sulfur trioxide is 0.01 moles. So now we need to find the new ratio. New ratio will multiply this one by 0.01. But before doing that, you check, because we want to calculate the volume of sulfur dioxide, this one. And we calculate the number of moles of sulfur trioxide. So you check the two species in which ratio they are. So they are in the ratio 1:2. So meaning we calculated number of moles for this sulfur trioxide, which is a 2. So to find number of moles of sulfur dioxide, you need to have the number of moles of sulfur trioxide. So number of moles of sulfur dioxide is equal to half number of moles of sulfur trioxide. This will be equal to half of 0.01. This gives us 0.005 moles. But our question is calculate the volume of sulfur dioxide gas fed in the reaction. So volume is equal to number of moles times molar gas volume, which is equal to 0.005 multiplied by molar gas volume is 22.5. This is equal to 0.11 cubic decimeter If we want to change it to cubic centimeters, you just multiply it by 1000. This will give us 110 cubic centimeters.